So this is just a quick little summary of the calculus of motion. If you're in Calc BC, this is all hopefully very familiar to you. If you're in Calc AB, it will be familiar to you shortly. And if you're in regular Calc, when you get to this in January in regular Calc or February, you're going to think it's so easy. Okay, so basically you really just want to think of it like the slopes and areas of the graphs. Okay, so when you move down the motion graph this way, right, you find the slope. Okay, so the slope on the position graph gives you the velocities. Okay, and then the slope of the velocity graph gives you the acceleration. All right, this works even when the acceleration is not constant. Okay, the equations, like these equations, only work if the acceleration is constant, but the derivative works no matter what. Okay, that's why we need to have it. All right, so basically, if you take the derivative, all right, all you're going to do is constants go away. All right, and if I take the derivative dy, or x it could be, with respect to time, then I'll show you on the next page in a minute. Basically, all of the exponents lower by 1, and then this 2 moves to the front. So that cancels out, and you get at. This exponent t to the 1 turns into a t to the 0, which is just 1, and then you get a constant. Okay? And then same thing when you take the derivative again, the constant goes away. And then at, that's again t to the 1, becomes t to the 0, so that just gives you a constant acceleration. Okay, I'll show that a little better on the next page. Okay, so that's really pretty simple. Simple taking derivatives. A lot of the calculus that we actually need in this class is really simple derivatives and integrals. Okay, so there are a few advanced things, but not too many. So we'll see. Okay, now when you take an integral, right, basically that's like taking the area. Okay, so when I take the area of the acceleration graph, I get the change in velocity. When I take the area of the velocity graph, I get change in position. Okay, and this is what we've been practicing. All right, so basically when you start with a constant, you're taking the integral. Now, if you don't know how to take integrals yet, that's fine. I'm going to wait for your calculus teacher to teach it to you correctly. But those of you that know it already know it. But basically kind of think about doing this backwards, right? That's kind of the easiest way to think about it. So I usually think about it, because I can't really quite remember that much, if I was going to take the derivative, what would that look like? Okay, so here this a becomes at, and then you always have to add a constant. This becomes this gets a t, and then you add a constant. Okay, so basically that's all that you need to know about that. Okay, and this is a little bit better video that has a little more information if you want. Okay, and then this next slide, on your next slide deck, this is just some other notes that I took from somebody, right? So basically you're doing the average velocity is delta x over delta t, right? That's what we were talking about, sort of like a bigger interval, right? Like a secant line, like a bigger interval. And then when you shrink that interval down, like we did yesterday or last class, you're basically taking the interval to be so small that now we call it dx dt, meaning a very, very small interval. And that's how we get that tangent line slope. Okay, so if you want to say it calculus-wise, velocity is the derivative of position with respect to time. Okay, same thing with acceleration, right? Average acceleration is change in velocity over time. Okay, oftentimes for us, that delta v delta t and dv dt are going to be the same, because it's going to be a constant acceleration. Okay, but not always. All right, and so acceleration is the derivative of velocity with respect to time. Okay, this is going to be important a little bit later. Okay, a lot of times there'll be an a in the equation somewhere, and you have to substitute this dv dt and then solve it, right? And we'll get to that more probably in forces. And then you can also say acceleration is the second derivative of position with respect to time, right? You took the derivative, and then you took the derivative again. Okay, so that may or may not be a new notation for you. Okay, all right, and then this is what I was talking about here, right? You basically take this n, you move it to the front, and then you lower the exponent by 1. That's how you take the derivative. Okay, and that is it. And then you're going to go ahead and do these next 2 pages for practice.